This video is going to show you how to do acceleration problems with a few examples. So in your first example, you see a bicyclist increases her speed from 10 meters per second. So this is your first speed. So that is going to be initial. And you're going to see 15 meters per second, which is her final speed. So that'll be VF. So you should remember the initial and V final from your packet. And then this value here is 3 seconds, which is time. So that labels all of our variables. So the first part in finding acceleration is to find change in velocity. So remember that delta, or that triangle, V. So change in velocity equals my final minus initial. So in my problem setup, I'm going to have 15 meters per second minus 10 meters per second. And again, if any time I'm going too fast, remember you can pause the video so you can catch up with writing this on your worksheet. And that's going to equal 5 meters per second is our total change in velocity. Okay, sorry, my 5s and my seconds look a lot alike, so the bottom number is the S. This is the number 5. And then for acceleration, remember our whole equation is VF minus VI over time. Okay, and acceleration is their variable. So if I'm going to substitute in, I'm going to substitute in my total change in velocity. So I'm just going to do the 5 meters per second that I calculated from part A. And then I'm going to divide that by my time. So here's where the 3 seconds comes in. Okay. And again, that means we are going to get 1.67. Now your calculator is going to give you a whole bunch of numbers. So we usually round off to 2 decimal places, or at least 2 non-zero digits. So if it would be 0.001357, I'd have 0.0013. And then it's really important to emphasize the positive. So this means our bicyclist is increasing her speed. And then I have to deal with units. So the unit part's a little strange. So you have meters per second divided by seconds. So what that gives you is really meters per second times, you take the reciprocal of 1 over seconds. So this is going to give me meters over seconds squared. So it's meters per second, which means how much does the speed change every second. So that's why you get that strange unit, meters per second squared. That's how that is read. So remember, the red here is an S, not a 5. So that would be your final answer, positive 1.67 meters per second squared. In our example number 2, a car slows, so that's important. So remember, that's our negative acceleration. So 55 miles per hour is going to be our V initial, because that's what we're starting with. And the 25 miles per hour is going to be our V final. And again, we have 10 seconds, which is our time. And we are solving for acceleration. So I'm going to write the equation for acceleration. So VF minus V initial over T. And I think you're going to be more successful with solving problems if you always write the equation down. Now, remember we did this part separately, so we're going to use this as parentheses, because if you don't use parentheses for this or solve it separately, you're going to get an order of operation error. So my final is 25. Okay, remember miles per hour can also be written this way, and we're going to use, I guess this would really be meters per hour. We scientifically use mph, but I know that isn't what you're used to. Minus 55 miles per hour. So I'm going to throw those i's back in now that we're getting rid of the mph. So that's going to be my change in velocity, and I'm going to solve for that. So again, 25 minus 55 is going to give me negative 30 miles per hour. So then I'm going to have, for my acceleration part, I'm going to have negative 30 miles per hour. And then all of that divided by 10 seconds. And that is going to give me negative, it's important you have the sign, 3 miles per hour per second. So another way of looking at this is whatever's on the bottom is going to stay on the bottom. So you kind of have two bottoms, or you can do that division by fractions, but this is a lot easier. So final answer, negative 3 miles per hour each second. So it's slowing down 3 miles per hour every second it takes by. And then we have another question here. What's another word for negative acceleration? So we have all of these multiple words that are called slowing down, decreasing, so we can have all of those. But as you can see, that really isn't one word. Decreasing acceleration. Sorry, this program I'm using is a little bit tough to write with. Okay. So there's a fancier term for it called decelerating. The deceleration. Is our single word for slowing down. For example number 3, our rider starts his motorcycle's engine. Okay, so that kind of gives you some information, and then accelerates to 100 meters per second. So if you see, there's only one speed, but this is going to be your final. So remember, we talked about this in your one journal entry. You are starting at 0. So the initial, since we're not moving, is going to be 0. I'm going to use meters per second so our units agree. So anytime you don't see two speeds and you're asked for acceleration, think about is one of them starting or stopping, because then your acceleration or your speed is going to be 0, and we can calculate acceleration from that. And then of course you need the 8 seconds as well. So I'm going to have 100 minus 0. And that's pretty easy. That's just going to be 100 for your change in velocity. Excuse me. So again, our acceleration equation is VF minus VI, so that's where this part's coming from. And then we're going to take that answer, which is the 100 meters per second, and divide it by our time, which is 8 seconds. And when you divide that, you get your 12.5 meters per second squared, because I have seconds on the bottom here, seconds on the bottom here, which is my meters per second squared. Okay, for guided practice, you're going to do this problem here, and you're going to do it as a T-chart. So on the work step, you're going to show me the work. So everything that I gave you up to this point has been the kind of the math part of it. So you're going to show me that setup, and then you're going to write in words why you're doing that step. So getting you to kind of put into words. So as you're thinking, I'm doing this step, you put your numbers here, and this is why you're doing that step. So you're explaining how you're gathering the information from the problem to right here. Please have me check your answer when you are finished. And then you can move on to the next part.